So how can I use a graph to solve? Solving equations and systems graphically. Okay. So you use a graph to solve an equation in problem 4.1. That was a while ago, or not a while ago, the last class. In what other ways can a graph be useful solution tool? Consider the following equation. This was x, by the way. Root 2x plus 3 equals x. So algebraically, I'm going to show you what to do, and then I'll show you how we can do this graphically. So if you have a radical, what's the first thing you should do when you see a radical? First thing you should do, square both sides fully, right? So the radical goes away on the left side, and the right side becomes x squared. Okay, great. That's easy, right? We square both sides. After that, you have a bunch of terms, 2x plus 3 on the left side, x squared on the right side. What should I do next? Yep, I love it. Thank you, Pierce. Okay, and then the next one should be pretty obvious too. What is this next one called? Factoring, right? And of course, you solve each one. So basically, square both sides, collect all terms on one side, factor. Oh, the styles gets funny sometimes. Factor and solve. So that's kind of an annotation, right? Like it's square both sides, collect all terms on one side. Let's factor, let's solve. Easy, right? However, this answer is not correct. I'll explain why. So how many solutions did you find? We found 2, right? And what strategies did you use? Basically just algebra. I don't know. I just move things around. Maybe they're talking about the whole undoing. We did a bunch of undoing, I guess. So there you go. Because remember, we said there was undoing, there was looking inside, and what was the other one? It was what was the other technique they called it? Oh, rewriting. Yeah, I didn't do any rewriting this. Well, kind of, I guess, by squaring both sides. Yep. Yeah. And also some rewriting. Now, she wants to check her solution. So she lets y equal 2x plus 3, and she lets y equal x. So now, how many solutions do you see for y equals 2x plus 3? Well, if you were to actually graph that, and just kind of trust me on this one, it looks like it touches the x-axis once, negative 1.5. I'll graph it for you guys in Desmos, but it looks like it does this, and y equals x. Looks like it does this. So it looks like they have one solution each. When I say solutions, I mean x-intercepts.
How do you know?
I'm just going to graph in the calculator right now. I just know how the graphs look. Well, algebraic, we got 2 solutions, obviously. But yeah, and by the way, if you ever want to do square root in Desmos, just try squirt, SQRT. It's kind of funny. 2x plus 3 and y equals x. Okay. So let me clear my screen. So how many times are these 2 graphs touching? Definitely at 3, 3, but definitely not negative 1. At negative 1, that's like over here somewhere, right? And negative 1, that's over here. So there's nothing common at negative 1, but definitely at 3 there is. They share something common. So according to the graphs, how many solutions do they have, or basically points of intersection? Just 1. In other words, how many intersection points do you have? Just 1. Those are the match solutions you found in part A? No. Because part A had 2, right? So algebraically, as a summary, algebraically, we have both negative 1 and 3. But graphically, we had just 3. This is huge. This is the whole essence. Just so you know, this is the whole essence of the fall semester. Not kidding, guys. It's about looking at things algebraically and graphically and how they're related. Clearly, there's a inconsistency here, right? So what gives? Is it -1 and 3 or is it 3? What is it going to be? We'll talk about it in the next page. So there's something called an extraneous solution. Extraneous means it's extra, right? It kind of sounds like extra. An extra answer. And it's going to sound weird, but that really doesn't work. So it's kind of a flaw in the system. So it's not a solution, even though the algebraic answer gave us that. So to be honest with you, the graphical solution is actually more reliable because you have to make sure what's happening graphically confirms algebraic. So 3 definitely for sure works. X equals 3 is a true answer. But x equals -1 is what we call an extraneous answer or extraneous solution. Because it only intersect once. So where would an extraneous solution appear on the graph? Obviously here and here. They're not touching at x equals -1. But they touch at x equals 3. That's why x equals 3 is a true solution. X equals -1 is not. Why the graphs not intersect at that point? That's because, well, that's kind of a deeper answer, actually, to be honest with you. Why did it not intersect at that point? Well, before I answer that question, any questions about what we've done so far? Algebraic, what happened? Graphical, what's going on? No? Okay. So why do they not intersect? That's because they have different y values. At x equals -1. They have different y values at x equals -1. Algebraic shows it, but that's because we squared, right? When you square something, what happens to negatives when you square something? That's why it shows up as a solution, but it's not true graphically because they're different y values. That's the reason why. So you had different y values when you graphed, but algebraically, because you squared, it turned a -1 to a positive, so it made it seem it was deceiving, basically. So you think of it this way: extraneous solutions are deceiving. Don't be deceived. How do you know it's deceiving? You got to check your work. Or graph it. Check your work or graph it. So let me clear a screen for a moment. Because when you had this again, x equaled √2x plus 3. When I plug in -1, what happens? Does -1 equal √1? No, because √1 is 1. So that's why it doesn't work. But if you plug in 3 equals √2 times 3 plus 3, 3 equals √9, 3 equals 3. Yeah, that works. Okay, this I'm going to actually have you guys do in your table groups, and I'll walk around and help you guys out. So you got two things here. You got 2x squared plus 5x minus 3, x squared plus 4x plus 3. So after solving, Dylan went to the bathroom. When his teammates examined his graph calculator, they found his solution. They only saw y equals x squared plus x minus 6. That's because he moved everything to one side. So how many solutions do you predict this will have? So what Dylan did was he combined he collected all terms on one side. So first of all, predict how many solutions you think this will have. This is two parabolas, by the way. Solve it algebraically. Where did Dylan get this from? I think I kind of told you how many solutions this will have. And how can you see the solutions in the graph of this? And explain why this makes sense. Okay, we'll give you guys about 3 or 4 minutes, work on it. So to predict how many solutions you think this will have, actually solve it, then look at what Dylan did, how many solutions that equation will have, and then just think about part D, and I'll check in with you guys in a few minutes. Okay, let's work on it, guys. Especially part B, that's a big one. Oh, let's just break that. Awesome. Well, time to call maintenance. Oh. Sorry, guys, a little dark here.
Yeah. Oh.
All right, I'm gonna come around and see how you guys are doing. Help you guys out. All right. So let's solve, guys. So you guys may go over to one side, bathroom. Yeah. Looking good, guys. Good. Good. All right, guys. Oh. Yeah, we gotta put something together. Get out. Okay, step one of those days. Yeah. Okay. Anyway, I would probably predict 2 solutions, guys. Mainly because you're gonna have a quadratic. And if you move everything over to one side, you should get this. So you factor the sucker, you get 2 answers, -3 and 2. So where did he get that from? He probably got that from combining like terms or collecting all terms on one side. And how many solutions this has? Probably 2, because it's 2 x-intercepts. And so how can you see this in the graph of that? Basically, you're looking for x-intercepts. Whereas here, you're looking for points of intersection. So let me do it really quickly on Desmos for you guys, and then we'll move on. So let me pull up Desmos here. So y equals x, 2x squared, plus 5x, minus 6. The next step is going to be x squared plus 4x plus 3. Okay, then I'm going to clear my screen. So clear they touch at 3 places, right? Oh, I messed up somehow. I messed up. Ah, -3. There we go. Okay, much better. Yeah, and let me zoom out a tad. Yeah, -3 and 2. But if you graph y equals x squared plus x minus 6, it's going to be, let me turn these off. Yeah, you're looking at the x-intercepts in this case. So it just depends which, basically either technique. So the whole point here, the takeaway, you might want to add this to your notes. Big takeaway. Why does this make sense? You have two methods for solving graphically. Two methods are graph each side of the equation, then find the points of intersection. Or two, collect all terms on one side then find the x-intercepts. Okay, so that's the takeaway. Questions? No? All right. Let's move on to 419. We got what time today? 2:10? 2:05. Okay. We'll see how the next one goes. If it takes a little while, then maybe we'll stop after that one. We'll save going for another day. 419. We're doing great. Okay. So let me sorry, I don't make these boxes show up. They're supposed to be x's. So let's say you got another kind of crazy situation. You got 20x plus 1, which is linear, and 3 to the x power, which is exponential. So again, you have 20x plus 1, which I know is linear, and 3 to the x, which is exponential. After she finished entering the equation, so she did y equals 20x plus 1, y equals 3 to the x. She got the graph shown here. So she probably thought, well, there's no solution. Because there's, you don't see points of intersection. How come she's not seeing any points of intersection? Yep, great, awesome. So why do you think the window is not large enough? We need a larger window. And so, so basically you want to expand, because it looks like they're getting closer together. So I'm pretty sure they're going to touch, right? So, and what should the solutions look like? Will the solution be a single number? Should it be coordinates of a point? Well, the solution should be the x coordinate. Always going to be the x coordinate. That'll always be the solution. But that's because you're solving for x. It's never the y coordinate. Of course, the y coordinates will be the same, but you want the x coordinate. But let's actually do this in Desmos right now. Okay. So let me go to Desmos. Let's see here. Put down these other ones here. 20x plus 1. And y equals 3 to the x power. Okay, let me clear my screen. They clearly touch. There you go. I mean, I'm zooming in, but it looks like that's probably the only place they touch. I mean, because as I zoom out, oh, actually, it looks like they touch somewhere else. Oh, look at this. Where else are they touching? This is the beauty about Desmos. Whoa, why is my computer? Oh, there we go. All right. Yeah, so it looks like it intersects at 4 and 0, which makes sense because that'll make the left side equal the right side. So let's go back to this stuff here. So Carmela started to solve first by subtracting. So basically we see two answers. X equals 0 and X equals 4. But let's say she started to solve by subtracting 1 from both sides. So now she's got Y equals 20X and Y equals 3X minus 1. She should get the same solutions. Yes, of course. Who cares that you move things around? You're still gonna get, it's still gonna happen, right? May the Y values be different, but you still get the same thing. So if I got rid of the 1 here and made it minus 1 here, still 4 is just 4 comma 80. You still have that. But that's a 0, 0 instead of 0, 1. So yeah, you still get the same thing. So yeah, that was a yes. And then discuss why she cannot solve the system algebraically. Well, how would you do that algebraically? 20x plus 1. Can you combine the x's? Yes, you can't combine the variables. Also, you guys have not learned how to undo an exponent. You will in the second semester. It's called a logarithm, which you may have heard if you have older siblings or friends who are older who've taken this class or taken pre-calculus or calculus. You will learn that in the second semester, which is kind of a big part of the second semester. But I've not taught you guys how to undo an exponent. So, but also you can't combine that. So you have an exponent, you have an x that's not an exponent. There's just can't be combined. Okay, I think we have time to finish off these notes. I think we're okay. Any questions so far? Okay, let's finish it off. Let's get it done. All right, last one here. Jackson was working on solving an equation. He graphed the following. So we're going to use f of x notation now. We haven't done that in a while. Equals 12 over x, and f of x equals negative x minus 3 squared plus 4. So there's the graph. Okay, there it is. 12 over x, just so you know, looks like this. I'm just going to redo it. I don't know why. Just feel like it. We'll go Christmas colors. 'Tis the season, right? 3, 4, and it's opening down. Okay, yeah, that's what's happening, right? So what equation is he trying to solve? Well, he's trying to solve this equation. 12 over x equals negative parentheses x minus 3 squared. Ellie, go ahead. Sure, yeah, go ahead. Yeah, go for it. That's what he's trying to solve. He's trying to solve that equation. Now, how many times do you think these will touch? How many points of intersection do you think we'll have? Clear the windows. The image that's already produced that's printed shows 2. But do you think it'll be more than 2? Yeah, probably down below as well. Yeah, it looks like they're going to eventually touch, right? Now, there's a vertical asymptote for 12 over x because x can't be 0. But the parabola is going to get there to wherever the other curve is. So looking at the graph here, what are solutions? Definitely, it looks like probably 2 and 4. X equals 2 and x equals 4 and 1 more. Kind of rhymes. No, I lied. I meant to say 3, not 4. My bad, guys. I meant to say 3. Because if you plug in 3, you do get 4 for y. And you plug in 4, you do get 3 for y. For each one. So definitely 3 and 4 for sure. And it's probably 1 more. So for parts C and D, just wrap up these notes here. Are the other solutions? Yes, there is. So I'd probably just go to Desmos. That's kind of your best friend. If I go to Desmos, let's punch him in. Oh, you have a question? Yeah. Can you give me a moment? I'll help you out in a second. We're almost done. So, there's a negative x minus 3 squared plus 4. Okay, cool. Here and here. Zoom out. Yep. They're touching at -1. So that's, you can use a table too in the graphic calculator, but I think Desmos is fine. So yeah, at x equals -1. Okay. So now he has 3 solutions. And so what you do is you could do 12 over -1 equals -12. And negative of -1 minus 4 squared plus 4. No, minus 3. So it'll be -16 plus 4, which is also -12. And also if you plug in 3, 12 over 3 and 12 over 4, that's 3 and 4. But if you did -3 minus 3 squared plus 4, you get 4. If you do -4 minus 3 squared plus 4, that'll be -1 plus 4, which of course is 3. So check, check, and check. They all check out. So the takeaway here is make sure the left side equals the right side when you graph, plug into the equation. But graph algebraically, some of these are hard to do. I think you could do this algebraically, but I don't want to because it's a little bit beyond what we've done in this class. So homework's on the next page. I left space. You could do the homework on here. You don't have to start a sheet of paper. So you want to get the homework done. Have nothing to do over the weekend, which is great. You can watch some NBA basketball. Go watch the Cavs right now. No, I'm just kidding. Or maybe they'll be here tomorrow. Do you think chance to be here tomorrow? The Cavaliers, maybe. Yeah. Anyway, it's kind of neat. We're watching ours on Sunday. So. I know we're in trouble if they lose. So. All right.